Okay, good day. So we're here for another video discussion for Physics 2, and today we're going to talk about resistors in series and parallel. So last video discussion, we talked about current, resistivity, and resistance. So pinag-usapan natin doon how current flows, and there are two ways. We have the conventional and the electron flow na tinatawag. We also talked about resistance, which is the resistance to current. Okay, and of course yung resistivity, which is affected by the different factors such as the length of the material, the cross section, and of course yung ating temperature. So today we're going to talk about resistors naman when they are connected in series and parallel connection. Okay, so itong series and parallel, kung narin or if you already have your idea about this series and parallel, you know that these are types of circuit connections. Kaya ng mga connections natin sa bahay, sa mga electronic gadgets natin, or sa kotse or sasakyan. Okay? So, bakit resistors ang naging topic natin dito? Kasi yung mga devices natin, mga appliances, mga loads na nakakonekta sa ating mga circuits, they are basically parang resistors din. Okay, kumbaga, they consume power. There is resistance in them. So, kumbaga parang resistors na rin sila. So, instead of using devices or loads sa ating circuit at yun ang gamitin natin sa discussion na to, we're going to use instead resistors. Okay? So, resistances in circuits. There are two ways to connect circuit elements. We have the first one, yung tinatawag nating series connection. So, what is a series connection at paano mo malalaman na series ang isang circuit? So, we have here 2 points. We have point A and point B. Okay? So, if you can move along or if you put your finger on the wire at A, okay, and if you can move along the wires to B without ever having a choice of which wire to follow, the circuit components are connected in series. Okay, so just like this. So from point A to point B, wala kang choices. Isa lang ang daan papunta sa B. So that means this is in series connection. Okay, when it is parallel connection naman, okay, if you put your finger on wire A, okay, and if in moving along the wires to B, you ever have a choice of which wire to follow, the circuit components are connected in parallel. So in this case, from point A to point B, meron kang three choices. You either go here, here, o di kaya ay dito. So there are choices. That means this is a parallel connection or parallel circuit. Okay, now question. Are these resistors in series or parallel? Well, here in this example, it's neither series or parallel. Why? Because there's no current. Okay? So para magkaroon ng current, you should have a source of EMF or kung ano yung mga sources of EMF natin, if you can still remember yung previous discussion natin, these are devices that provides EMF or electromotive force that causes voltage, which of course causes current to flow. Okay, so example nito is battery. So where is the battery here? Wala. So walang current, walang EMF. So there's no connection. Okay, so if you put a battery, for example, here, okay, so we have the battery here, and the charge or the the current will flow from here at pupunta ka dito. Then you have two choices, either dito, di kaya ay dito. So then this is a parallel connection. Okay, how about if it is connected like this? Okay, same lang siya dun sa nauna, pero the position of the source of EMF changes. Okay? So mapapansin ninyo, maaaring isipin ninyo, there are two paths, either dito o di kaya ay dito. But tandaan natin, current flows in only one direction. Okay? So if we are going to talk about yung ating tinatawag na electron flow, which is from negative to positive, then ang direction natin is papunta dito. Isang direction lang. Okay, so that is a series. If ang pag-uusapan naman natin is conventional flow, then that is from positive to negative. So, ito naman ang direction natin. Okay, still, one path only. So, this is a series connection. Now, ano yung pinagkaiba ng parallel at series when it comes to the voltage and the current? So, if resistors see the same potential difference or voltage, just like here, okay, they are in parallel. Okay, so ibig sabihin yan, yung resistors natin na ito and ito, they both have or they both see the same voltage. Okay, pareho lang sila ng voltage. Kapag the resistors naman see the same current, they are in series, just like this. Okay, so pareho yung current dito at dito. Why? Okay, kasi nga, isang path lang ito. Okay, so kung ano yung current dito na dumaan dito, yun din ang maging current na dadaan dito. Same lang. Okay? Now, dito sa parallel, ano naman yung current? Okay, dito sa parallel natin, magkakaiba yung magiging current natin. Depende sa resistance ng bawat resistor. So, tandaan natin, parehong voltage dito at dito. So, V is equal to IR. Okay, so kung parehong voltage, magkaibang resistance, then magkakaiba din ang kanilang current. Okay? Ayan. So, that is the current here. Dito naman, magkaiba yung kanilang magiging voltage. Okay? So, again, V is equal to I times R. So, kung magkaiba, or kung pareho yung kanilang I, yung current nila, pero magkaiba yung kanilang resistance, R, then magkakaiba din yung kanilang voltage. Okay? Ayan. So, again, sa parallel, pareho ang voltage, magkaiba ang current. Dito naman, pareho ang current sa bawat resistor, pero magkaiba ang voltage. Now, here's a circuit with 3 resistors and a battery. So, we have a battery here. We have resistor 1, resistor 2, and resistor 3. As you can see, these resistors are connected in series connection. So, current flows from here. Okay, and then papasok siya sa mga resistors natin. Now, in the steady state, the same current flows through all resistors. So, mapapansin nyo, okay, papasok yung current natin dito sa R1. Kung ano yung current na pumasok sa R1, yun din ang current na papasok sa R2, at yun ang current na papasok sa R3. Okay? So, applying conservation of energy allows us to calculate the equivalent resistance of the series. So, however, kahit pare-pareho ang kanilang current, there is a potential difference or voltage drop across each resistor. So, magkakaiba rin sila ng voltage. Okay? And kung titignan ninyo, yung I natin na pumapasok dyan, mas maliit yung mga I's dito sa ating bawat resistors. Okay? So, anong relationship nung pumasok na current dun sa current na dumadaan sa bawat isang resistors natin? Okay? So, an electric charge Q is given a potential energy QV. Okay? Bakit QV ang pinagre-represent natin ng potential energy? Remember, V is potential energy over Q. So, potential energy over Q times Q, magka-cancel yung dalawa. So, may one is potential energy. So, as it moves through the circuit, the charge loses potential energy QV1 as it passes through R1, etc. So, naglulose siya ng potential energy dito, dito, at dito. Okay? The charge ends up where it started. So, the total energy lost must be equal to the initial potential energy input. So, ibig sabihin nun, kung ano yung ipinasok na potential energy dito, yun dapat yung total potential energy na gamit dito sa tatlong ito. So, we say that yung QV na pumasok is equal to the QV in 1, the QV in 2, and the QV in 3. Okay? So, again, yung QV, yung potential energy na pumasok, that's the QV, is equal to the sum of the energy here, the energy here, and the energy here. Okay, yung nag-lose na energy sa tatlong yan, that is the sum of QV or yung pumasok na QV natin. Now, since common yung Q sa kanilang lahat sa mga terms na yan, we can divide all sides by Q. Ang maiiwan is V is equal to V1 plus V2 plus V3. Okay? So, again, ano yung meaning nitong equation natin na to? V is equal to V1, V2, and V3. Yung V natin, this is it, yung voltage ng battery natin. Okay? So, ibig sabihin yan, yung total voltage natin sa battery, or I mean, yung voltage natin sa bawat isang resistor, pag pinag-add natin yung tatlong yan, it is equal to here, this. So, for example, if this is 12 volts, okay, 12 volts for example, kapag yung R1, R2, at R3, kinuha mo yung kanilang voltage sa bawat isa, dapat mag-equal yan sa 12 volts. Okay? So, ibig sabihin yan, again, yung voltage natin dito, it is equivalent to the total voltage sa bawat resistors natin. Okay, now going back dun sa ating equation. So, yung formula natin ng V is IR. So, we can represent V1 as IR1, V2 as IR2, and V3 as IR3. Okay, pare-pare yung I lang nila. Okay, yung magkakaiba lang ng resistance. Okay? So, imagine replacing the three resistors by a single resistor having a resistance R such that it draws the same current as the three resistors in series. So, imagine natin, for example, instead of three resistors, pinalitan natin ng iisang resistors lamang na equivalent sa total ng resistance ng bawat isa. Okay, so what will happen? So, para maging ganyan. So, we have I here, okay, the current. We have the resistor here, the equivalent resistance. Okay? So, V, ang maging formula ng V will be equal to I, the current, times the equivalent resistance. Okay? And from before, we have V is equal to IR1 plus IR2 plus IR3. So, combining, since V is equal to IR equivalent and V is equal to this, then this IREQ or equivalent, I times the equivalent resistance is also equal to I R1 plus I R2 plus I R3. And ito yung kalalabasan. Okay? So again, this one is equal to this one since pareho silang equal to V. Okay, so pinagsama na natin. Okay, and since pare-pareho silang may I, which is common sa kanilang lahat, pare-pareho, we can divide all sides by I. At pag dinivide natin sila by I, what will happen? Ang maiwan is R equivalent is equal to R1 plus R2 plus R3. Okay? Ayan. So that is how you get the total resistance of resistors connected in a series connection. So for resistors in series, the total resistance is the sum of the separate resistances. We can generalize this to any number of resistors. Req is equal to the summation of individual resistance. Now, here's another circuit with three resistors and a battery. Okay, as you can see, this is connected in parallel. So there are three paths na pwedeng pasukan ng ating current. So different current flows through different resistors. Okay, so yung current natin dito, dito, at dito ay magkakaiba. Okay, but the voltage again is same lang sa kanilang tatlo. Okay, so same voltage, magkakaiba ng resistance, kaya magkakaiba din ng current na dadaan sa kanila. So again, the voltage drop across each resistor is the same. So in the steady state, the current I splits into I1, I2, and I3 at point A. So yung current natin na nanggagaling dito, pagpasok sa A, ay mag-split into I1, I2, and I3. So I1, I2, and I3, okay, yung tatlong yan, okay, will recombine dito sa point B at babalik siya dito. Same lang nung magnitude nung lumabas, yung pumasok na current. Okay? So therefore, the net current flowing out of A and into B, okay, so from A to B, pag kukunin mo yung net current, you just have to add I1, I2, and I3. Okay, pag-addin mo lang in order to get the net current. And because the voltage drop across each resistor is V, okay, so then I1 is equivalent to V over R1, I2 is equal to V over R2, and I3 is equivalent to V over R3. Now imagine placing the three resistors or replacing the three resistors by a single resistor having a resistance R such that it draws the same current as the three resistors in parallel. So just like this one. So instead of three, we only have one resistance, a resistor with R as the equivalent of the three resistors. So from above, again, yung I is equal to I1 plus I2 plus I3 natin is replaced by V over R1, V over R2, and V over R3. So we have V is equal to R equivalent equals V, okay, over R1, okay, V over R2, and V over R3. Okay? So, since voltage is the same sa lahat ng yan, we can divide or divide each one by V at ang maiwan sa atin is this one. So 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So we can generalize this to any number of resistors. 1 over R equivalent is equal to the summation of 1 over the individual resistances. Okay, so anong ibig sabihin nitong equation na ito? So, ibig sabihin nito, yung ating R equivalent will always be smaller than any of the individual resistances. Okay, so pag kinuha ninyo yung equivalent resistance, mas mababa siya kaysa sa any of these three. So for example, if R1 is 2, R2 is 3, and R3 is 4, then ang expected value natin ng R equivalent is less than 2. Okay? Ayan. So, ibig sabihin nito, kapag ang resistor is connected in parallel, bumababa yung total resistance nung circuit natin. Okay po? Ayan. So, in summary, so again, we have if the connection is series, we only have one path ng movement natin or ng current natin. Unlike sa parallel, may iba't iba tayong options. Okay, and ito yung ating formula for series, and this one naman in parallel. So let's have some sample problems. Okay, so for example, suppose the voltage of the output battery is 12 volts, and the resistances are R1 is 1 ohms or 1 ohm, R2 is 6 ohms, and R3 is 13 ohms. So question A, what is the total resistance? Question B, find the current. And question C, calculate the voltage drop in each resistor and show that this add to equal the voltage output of the source. Okay, so how do we solve this one? First, let's solve letter A. Okay, so this is a series connection, as you can see. So, ang hinahanap sa A is the total resistance. So, if you can still remember, sa ating series connection, we have R equivalent or equivalent resistance is equal to R1 plus R2 plus R3. So, R1 is 1 ohm, R2 is 6 ohms, and R3 is 13 ohms. So, we just have to simply add the 3, and we get a total of 20 ohms. Okay, so again, the equivalent resistance is uh, computed by just adding the 3 resistances. So 1 plus 6 plus 13 is 20 ohms. Okay, next, letter B. Find the current naman. Again, sa ating series connection, we have the same current sa ating mga resistors. So I is the same for the 3 resistors. At since ang formula natin is I is equal to V over R. Okay, nakuha na natin yung equivalent resistance dun sa ating tatlong resistors at meron tayong voltage which is 12 volts. So I, or current, is equal to V divided by R. So that would be 12 volts divided by 20 ohms. Okay, so that would give us a current of 0.60 amperes or ampere. Okay, so that's letter B. Next, calculate the voltage drop in each resistor and show this add to equal to the voltage output of the source. Okay, so gaya ng sabi natin dati, pare-pareho ang current natin sa series. Okay, pero magkakaiba ang voltage sa bawat resistor. Okay, at pag pinag-add natin yung voltage dito, dito at dito, dapat mag-total siya dun sa total voltage ng ating source or yung ating battery. Okay, so yan ang ipapakita natin. So let's solve muna the voltage in R1. Okay, dun sa ating R1. So ang formula natin would be okay, so let's calculate the voltage in R1. Okay, so ang ating formula will be V1 is equal to I times R1 or V is equal to IR. So meron na tayong I, ang nakuha nating value ng I is 0.60 amperes. Ang R1 natin is 1 ohm. Okay, so anong magiging voltage natin sa una? Again, V is equal to IR. So that will be 0.60 ampere times 1 ohm. And we're going to have 0.60 volts. So sa ating R1, ang ating voltage is 0.60 volts. Now, sa R2 naman, again, same lang, same formula. This time, V2 is equal to I times R2. So, I natin, again, is 0.60 ampere. Ating resistance naman is 6. Okay, so 0.60 amperes times ampere times 6 ohms is equivalent to 3.6 volts naman. So for R2, ang ating voltage is 3.6 volts. And finally, for R3, same formula, V3 is equal to I R3. So I is 0.60 times 13 ohms. That would be 7.8 volts. Okay, so ipakita natin na same yung total voltage sa tatlong iyan, pag pinag-add natin ay same lang dito. So again, sa R1 natin is 0.6. Okay, plus R2 is 3.6. Okay, so that would be 4.2 plus 7.8. It would be 12 volts. Okay, so napatunayan natin. Okay, next sample problem naman. Let's have a parallel connection. So, let the voltage output of the battery and resistances in the parallel connection dito be the same as the previously considered series connection. V is 12 volts, R1 is 1 ohm, R2 is 6 ohms, and R3 is 13 ohms. Question, what is the total resistance? Find the total current and calculate the currents in each resistor and show this add to equal the total current output of the source. Okay, so let's start with letter A. Ang tinatanong sa letter A is the total resistance. So, for this, we have the formula 1 over Req is equivalent to or equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so if you're going to input the given, it would be R1 over R equivalent is equal to 1 over 1 ohm plus 1 over 6 ohms plus 1 over 13 ohms. Thus, ang kalalabasan niyan, 1 divided by 1 is 1. 1 divided by 6 would be 0.1667. And 1 over 13 is equal to 0.07692. And pag pinag-add natin yung tatlong yan, that would be 1.2436. Okay, so again, we have 1 over Req is equal to 1.2436 over ohm. Okay, now, to get the R equivalent, cross-multiply natin yung R equivalent pataas at yung 1.2436 naman pababa sa ibaba ng 1 sa kabilang side. So, 1 divided by 12436 is equal to 0.8041 ohms. Okay, so as you can see, yung ating total resistance is way smaller or smaller than the smallest resistance natin dun sa ating parallel connection. Ang smallest resistance natin ay 1 ohm. Okay, at ang ating total or equivalent resistance is 0.8 ohms lamang. Okay, this is predicted na. Okay, so that is our total resistance. Next, find the total current. I naman sa ating equation. Sabi natin kanina sa ating parallel connection, there will be same voltage sa tatlong yan, but yung ating current ay magkakaiba. So, how do we solve for I? Okay? We use the formula I is equal to V over R equivalent, or I is equal to V over R. So, yung ating V natin is given na sa ating equation, sa ating problem, 12 volts. Yung ating R equivalent naman is na-solve na natin, that is 0.8041 ohms or ohm. Okay, we just have to input that sa ating formula. So we have I is equal to 12 volts divided by 0.8041 ohm. And that will give us 14.92 amperes. Okay, yung ating total current. Okay, next. Letter C. Calculate the currents in each resistor and show this add to equal the total current output of the source. Okay, so ang gagawin natin, in order to get the current of each one, we're going to use the formula I is equal to V over R. Yung R natin, gagamitin natin yung resistance ng bawat resistors instead of the R equivalent. Okay, so for R1, we have I is equal to V over R1. So that would be 12 volts divided by 1 ohm, and that would give us a current of 12 amperes. Sa R2 naman, again, similar formula, I is equal to V. This time, R2 naman ang gagamitin natin. So that would be I is equal to 12 volts divided by 6 ohms. And that would give us 2 amperes. And finally, I3 or I in resistor 3, again, same formula, V over R3 naman. So that would be 12 volts divided by 13 ohms. And that will give us 0.92 ampere. Now, kanina ang ating total total current is 14.92 amperes. Okay, so dito sa ating individual currents sa bawat resistors, pag total kaya yan sa 14.92, let's see. So 12 amperes plus 2 amperes is 14 plus 0.92 will be 14.92 amperes. Same lang dun sa ating equivalent current or total current. Okay, so that is um, series resistors in series and parallel. So for your activity, to follow na lang yung activity natin after this.